Hi, this is Mr. Shumway. This video clip explains how, if you were given a random circle and a random point outside the circle, how you would construct a line through the point that is also tangent to the circle. Go ahead and try this on your own before you watch the video. But first you may want to see, if you don't understand what that means, let me show you an example of what that means. So this random circle and a random point C, I constructed a line through point C that only touches that circle at one point. And to verify that it is tangent, we'll go ahead and measure the angle between that point and the center. It's 90 degrees. So if that line is tangent to the radius, then it is perpendicular to the radius, then it is tangent to the circle. Perpendicular is 90 degrees. Sometimes you can't see those labels very well. You can move them so you can see them better. So go ahead and pause the video at this point and create a random circle and a random point and try to find that point G that would make that 90 degrees. Oh, another thing you need to do is you need to be able to change the size of that circle and it would still stay 90 degrees, or move that point and it would still stay 90 degrees. So that construction needs to be based on that circle and that point, so that if either of them move, it still stays tangent. So here's how you would construct a line tangent to a circle through a point not on the circle. Let's just create a random circle. Let's move this out of the way first. Random circle. A random point. Let's go ahead and create a line segment between the center of the circle and that random point. Let's bisect that segment using circles, going from this one end of the segment to the other from each direction, intersecting those circles, joining those intersections with a line segment. Great. Now we're going to intersect those two line segments, and now I'm going to use that intersection as the center of a circle and go to the center of the original circle. So it has a radius of half of the distance between the center of the circle and that random point. Now I'm going to intersect the original circle and the circle I just created to create a point, this point J. Now I'm going to create a line, construct a line from point C to that point I just made, J. It looks like it might be tangent to that circle. Let's verify it with an angle. It says that is 90 degrees. That verifies it. Okay. So now it might be worth trying to explain why that works. So I knew, let me just show you a triangle inside a circle where one side of the triangle is the diameter. So it goes through the center of the circle. So here's a triangle in a circle where one of the sides of the triangle goes through the center of the circle. So this line segment from M to N is the diameter of the circle. Now if I measure the angle of this other angle is 90 degrees. Now I created this point O at random. Is it always 90 degrees even if I move point O? As long as it stays on the circle, I can move that point anywhere and still the angle is 90 degrees. So since I knew that was true, that led me to, on this construction, say, well, I need to create a circle with so that the diameter is from the center of the original circle and C, this random point. So once I had this circle created, then I knew I just needed to find well, I needed to have the center of that first, and so that's why the bisector. So I got H being the center, and then where that circle intersected the original circle, I knew that would be 90 degrees. Now if I took J off of that intersection, it could swing around this circle and still be 90 degrees, but if I swung it right back to where those two circles join, it's 90 degrees and tangent to that circle. Don't know if that explanation helps, but we ought to verify that it stays tangent as we change the size of the circle and move the point. So I'm going to go ahead and hide a few, because we don't need these segments. We don't need these circles. Don't need those points, but they're not in the way so much. So if I were to change the size of that circle, it still stays tangent. I guess I need one of those segments back. Was it? Maybe I never made that segment. I'm going to go ahead and make that segment, just so you can see where that angle is. Yeah, so if I change the location of point C, it still stays tangent. So that does accomplish our goal of, given a random circle and a random point outside the circle, we were able to construct a line through the point that is also tangent to the circle.